So we have a function here in the graph, and we also have an equation of a transformation of that function. This transformation actually has two parts to it. We have this 3, and we also have the 2. The 3 is going to be a vertical stretch, and the 2 is going to be a horizontal stretch. Now, to graph the transformation, we actually need to do this step by step. We need to deal with each step individually. It doesn't exactly matter which order we deal with these stretches in, so we'll just go from front to back. So the vertical stretch, each point along the y-axis is going to be multiplied by 3. So we have this first point at 0, 0, height of 0 multiplied by 3 would keep that point at 0. Second point at 1, 1, it's at a height of 1, multiply that by 3, now it's going to be up here at 3. Next point at 4, 2, it's at a height of 2, we're going to multiply that by 3, it's going to be at a height of 6, which goes off the graph, but it's roughly there. Last point's at a height of 3, it would be at a height of 9, which is actually going to go off the graph that we have. So now to graph this out, we'll keep the same shape idea. And we get that piece as the vertical piece. The horizontal stretch, we have a 2, but horizontal transformations always do the opposite of what we'd expect. So instead of multiplying the points by 2, we're going to divide them by 2. So again, we're going to go from the red graph, because this is now a chain. First point at 0, 0, horizontal position of 0, multiplied by 2, again still at 0, so it'll be red on top of itself. Second point that was moved up to 3, it's at a horizontal position of 1. 1 divided by 2 is going to put it at a half, it's going to move inside to there. And the last point that we have that's off the graph, it's at a horizontal position of 2, which is going to be divided by 2 to put it at horizontal position of 4, divided by 2 to put it at a horizontal position of 2, so it's going to get moved in there to that. Again, we'll graph this out, and it's going to look about like that. Moving on to example B. B's been given in a bit of a confusing manner. We have f of 3x plus 6. We have two transformations, but they're not 3 and 6. In order for this to actually work, we have to factor out that 3. So really this would be y equals f of 3 bracket. Sorry, Mr. Bracket, f of 3 bracket x plus 2. So now we have our 3, which, like in example A, is a horizontal stretch. And our 2 now is a horizontal shift. So we'll deal with the 3 first, just because we're going to go left to right. First point at 0, 0, horizontal position of 0, which will be divided by 3. Stays at 0. Second point at 1, 1, horizontal position of 1, divided by 3, puts it at 1/3, which will be about there. Next point at 4, 2, 4 divided by 3, puts it at 1 1/3, 1.3, puts it right about here. And our last point at 9, 3, 9 divided by 3, moves it to a horizontal position of 3. And we'll graph it out. The horizontal shift is going to take all the points and move them to the left 2. As it is a horizontal, it does the opposite of what we'd expect. So a +2, we'd expect it to move right. It does the opposite, it'll move left. So we go from the red graph again, because we're making a chain. Point at 0, 0 moves left 2. Point at about 1/3 moves left 2. Point at 1 1/3 moves left 2. And the point at 3 moves left 2. Connect those up. Now this shift that we did in green, that's our final answer, should not have changed the shape of the red graph at all. It should have just changed the position, which is what it did.